Welcome to Intralogistics Insiders, brought to you by Sinaos. Explore the latest trends, challenges, and innovations in intralogistics with industry experts. Welcome to Intralogistics Insiders podcast. We have today Tobias, co-founder and Chief Growth Officer at Voraus Robotik. So welcome to the show.
Welcome. Thank you for inviting me.
So can you tell us a little bit, what's the origin of Voraus?
The origin of Voraus. So let's say it's a little bit complicated because we have a long story. So basically the company was founded, if I remember correctly, in 2017 as Voraus Robotics. So we developed a cobot really from the scratch, greenfield approach. So we did everything on our own. So software development, firmware development, electronics, working on safety certification. And then after a couple of years, when the product was, let's say, almost ready, somehow we realized that the cobot market is a little bit more complicated than we expected. So we saw that the growth rates were not as high as predicted, and we were afraid that we will enter into a fierce competition, mainly driven by costs or by price. So we decided to make a pivot and let's say sold the hardware assets and focused mainly on software, because once we developed the software for the robot, we already took care of open interfaces. So we implemented a Python interface so that high-level programmers can really program a robot in their favorite language. And we also implemented a no-code graphical interface. And this was very well appreciated by the market. And then we took this technology and did not only focus on robots, but on entire automation cells, because robots, of course, are a very fun part, very interesting part of an automation cell, but mainly only, let's say, 20% approximately. And you have all these grippers, conveyor belts, smart cams. So everything needs to be integrated and needs to work together. And that's what our software is capable of.
Okay. What is the biggest challenge that you saw in the industry where you need this no-code or low-code solution?
The biggest challenge way, I'd rather like to say there are a lot of challenges. So let's put it on a more high-level perspective, if you agree, before we are going maybe into technical details. I think if I look at an automation cell, we have all these different components, and usually each component is provided by a different supplier. And every supplier has its own software development suite, has maybe even its own programming language. So, for example, structured text for PLCs, KRL for programming a KUKA robot, KRL for the FANUC robot. And this makes it very complicated, because for each of these components, you need an expert. And these experts today are already hard to get. And this makes the development period very long and very expensive. And this is, from a high-level perspective, I think one of the biggest challenges, because what we also see is that automation business is growing, not only industrial automation, but also in hospitals, for example, in labs. So everywhere people start to automate. So the demand is increasing, but the number of experts is limited or even decreasing. And this will cause, or this already causes, a huge gap. And the companies are facing problems. And as we open the market with the high-level programming language, now we have, I think, 10 million Python programmers all around the world. So suddenly, almost everybody who has a technical background can program and orchestrate an automation cell. And I think this is the biggest advantage. So from a high-level perspective, yeah.
You mentioned Voraus solution as a middleware. Where does it start at the top and where does it end at the bottom?
Okay, where does it end? So we provide, if necessary, a real-time environment. So it's a patch preempt Linux we provide. And then we have driver layer That means below the driver layer, we have the robots. We have a Ethercat master, for example. We can communicate with PLCs. And then we have an application layer. So this application layer, it's either applications we offer or the customer can program on its own. And we have an interface layer. So it can be a graphical interface layer, for example, no code programming, dashboards, for example. And thanks to this open architecture, it's quite easy to link your automation cell, for example, to existing warehouse management systems or ERPs or mobile robots, for example. Yeah. So this is the middleware structure. And for the developers, we try to open the IT development suites. So I think you know this line 8, the DevOps 8, and this becomes accessible if you use a high-level language. So we think that a supplier of software or for automation should not prescribe, okay, you need to use my software development environment. I think, or we believe, that there are so many good tools all around the world which are state of the art, which are not limited, which are open. So the idea is to open these or to use these already existing tools to program OT, operation technology. So use the IT world, which is existing, the DevOps, the, for example, static code analysis, automated testing, version control, and so on. Everything is here. And use these tools and enable the Python programmers to use the IT world to program OT. So this is the big promise, merge of IT and OT. Okay. So that's the other perspective from a developer's perspective. Yeah.
I will get a little bit lost with middleware. So
sorry.
Let me just understanding when we go, for example, if we have a cell with a robot,
yeah.
You are providing the middleware to program that robot?
Yes. So we have different...
Or is it the high-level action that you're commanding the cell?
No, there are different ways of integrating a robot. So it depends on the level of cooperation. So one way is that we really interface the Ethercat. So we do this if we have a very close cooperation.
So you send like CSP commands to each axis?
Yeah, velocity,
you do the
torque, control, yeah, on for each axis, yeah. On the Ethercat. If we don't have, such a close cooperation, so we use the already existing interfaces like RSI, for example, from KUKA, and use this interface to control the robot. And we provide a proper API, and you can use this API to program the KUKA robot. And the nice thing is, as this API is more or less standardized, you can switch from KUKA to FANUC. And you don't need to change your programming. So we are hardware agnostic in that way. Yeah.
Okay. Where do you see the biggest value in your solution in terms of the levels? Because you went down to a very low level programming of the robot with the kinematics or whatever, or more middle, interface with a robot.
So I think the biggest value really is that we open automation to the IT world. I think this is the biggest value. We can somehow reduce the need of these experts I mentioned before. So everybody who is familiar with a high-level language can program an automation cell. I think that's the biggest step. And the other value, maybe let's say more from an investment perspective, as we have these open interfaces and as we have this testing infrastructure or open the door to the already existing testing tools, your automation cell becomes future-proof. So if there is, for example, a better smart cam, you can integrate it very easily. You can test it. You can test things against a simulation, and then you can deploy the same code which was tested to the real automation cell. So usually in automation you sell, if the system is running, never touch it again. And I think this will change because technology changes very quickly. The products which are produced by an automation cell are changing. Lot sizes are decreasing. So we will have these requirements that an automation cell needs to be updated, needs to become future-proof. And I think this is a paradigm shift.
It is not for companies are used to program these robots, for example, or the cells. They already have people that know about this. Is the process of this transformation for them complex? Or what does it require to do this transformation? It's a change of paradigm at the end.
At the end, yes. So if you have, for example, people already familiar with PLC programming, so there are two possibilities. You can use your PLC code and your PLC, and we integrate the PLC via OPC UA, for example. So no need to get rid of already existing tested, rock solid structured text. So you can keep this. But if you start, okay, I want to have new functionalities, those people, as they can already program, they need to learn maybe a new programming language, but then they can do it on their own and move, for example, to Python or any other high-level language.
What I understand that this is a lot about flexibility.
Yep.
So my question is, how important is going to be flexibility, and what role is going to be playing software in this new era of flexibility?
So, software is, from my perspective, is the enabler. So if the software is not or does not provide standardized interfaces and is, let's say, the software itself offers a high-level way of programming, then you're not flexible because you're always dependent on a specific supplier. And I think this is the core functionality or the core benefits the Voraus core, as we call it, really delivers open and standardized interfaces. And this opens the door to be flexible. So, for example, we have one application in palletizing. So we are palletizing small boxes, integrating smart cams, standard application. Now the customer says, okay, but I also have these nice mobile robots. Can you integrate them? And then we can, okay, give us the interface. We look at the interface, and then within a couple of basically hours, we are able to communicate with the server of these mobile robots. And this is something I think customers are really appreciating, because you can now develop your degree of automation step by step. You don't need to do the big bang integration and then never touch it, but you can do it in small, more convenient steps and really look whether it's working and it's providing the benefit you're expecting. And once you're happy, you can make the next step.
We have seen a huge effort in mobile robotics, for example, for this standardization with VDA 5050, for example. How do you compare between mobile robots and traditional robots or collaborative robots standardization?
Good question. So I think in general, in the automation world, it's a little bit more complicated because we have these, let's call it, these big players we all know. And of course, they say we are setting the standards. And there are also attempts to develop standards for robots, for example. But this is not really, at least at the moment, not really appreciated by the market. So a lot of big manufacturers come with their own languages, come with their own interfaces, with their own interface definition. Of course, there are attempts, but not in that broad area as we can see it maybe in the mobile market. I think that's not the case. So we are more focusing on, let's say, a little bit, if you look at software layers, a little bit lower, so TCP IP, OPC UA at these interfaces. And then once you have the tools to program interfaces or APIs, it becomes very convenient. But I don't think that we have this way of standardization, even if I look at the field bus level. I mean, we have EtherCAT, we have Profibus, we have Profinet, and anything else. So there are standards, but a lot of them Let's put it that way.
From your own experience, there have been efforts for many years for OPC UA, for example, to become this standard, but also EtherCAT is playing very, very strong, especially for motion control related applications.
Hard real-time requirements.
Where do you see the future of this?
Sorry?
Where do you see the future, or where do you see the trends are going?
So one big trend is, from my perspective, the TSN, time-sensitive network, somehow enabling IP communication in real-time environments. So OPC UA is, at least from my knowledge, not hard real-time capable. So not in the microsecond level as EtherCAT is, for example. But TSN, I think, may be a very promising technology, because then you have the possibility to communicate even with cloud infrastructure on a hard real-time level. And this opens the door to remove more dedicated hardware devices you have in or nearby your automation cell into the cloud. And then, of course, once again, you have all these nice, let's say, cloud features. So I need more memory, I need more computing power. I mean, that's just a few clicks. And that's very convenient in the IT world. And I think time-sensitive network could be an enabler to achieve this. Then you don't need all these nice, fancy edge devices, local IPCs, and so on. You just need a reliable real-time communication to a cloud server. Yeah, that would be very promising.
Efficiency, both in warehouses or production plants, depends on many factors. You know, machine builders, for example, try to make the fastest machines to process materials or to assemble stuff, but also the logistics and intralogistics are also involved into this. So all of this is connected. Based on your experience with this middleware solution, where do you see the biggest opportunities right now for warehouses or for factories to increase this operational efficiency?
So what we, at least from our customers, what we see is a big demand in these commissioning tasks. So you have these warehouses delivering these small boxes, then you have a robot picking items according to an order, and then you make everything ready to ship it. So this is something where we see that the gripper technology somehow advanced, because you have a variety of goods you need to grip and pick and place. And we also see that the development in computer vision now makes these tasks more and more feasible. Maybe not for every item, because especially if you have flexible items, unsorted, that's still a mess from a computer vision perspective. But I think we see a lot of progress here. So this is something. And at the same time, for the companies, it becomes more and more difficult to get the workers which are ready or willing to work 8 hours and just do some manual pick and place tasks. So this is something. And then what I think the next step is to connect or to link these commissioning cells then with mobile robots, because once package is ready, somebody needs to take this package and, let's say, move it to the truck or to a different storage place or whatsoever. This is at the moment still done, at least what I saw, very often manually. And then I think this would be then the next step. So connect commissioning with intralogistics, mobile robots. Yeah.
This podcast is brought to you by Synaus, the all-in-one intralogistics platform, orchestrating material flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit synaus.com to learn more. So software is going to play a pivotal role in both intralogistics and factory automation. What do you think are the roles that will be most important in the coming years for companies?
The roles, so you mean on a let's say, org chart level?
Yeah, what type of people will be needed to be able to implement, maintain, to do these commissionings?
So what at least what we have seen with our company. So we have these guys, which I have a profound background in IT. So they are familiar with all these, let's say, high-level programming stuff, with DevOps, with cloud. And those people are now entering, let's say, more traditional automation production companies. And we experience somehow that they are shocked, because a lot of software which is currently used from their perspective is completely outdated. So like structured text. So I think they feel that automation is somehow stuck in the MS-DOS world. So to make it a little bit more black and white here. And they have no understanding why all these things they are used to, so automated testing, static code analysis, versioning, and why this is so difficult in the OT world. And those people are now working on this paradigm shift. So it's somehow head of digitization, head of automation, head of robotics. I think those people are very crucial to take automation to the next level, because they have now have a different background, a different perspective, and they are really asking, why are things the way they are, and why does it seem to be more complicated to deploy a program as I am used to it at my former company, which was, let's say, more IT or whatsoever based. Yeah. And those people are really driving the paradigm shift. Yeah.
Change is always difficult. What are the key things that the people responsible for this change need to understand in order to be able to do this change?
What do they need to understand? That's a good question.
What are the key ideas they need to understand in order to be able to implement, for example, your solution, to understand the standardization, flexibility?
I think there are maybe two things. So the first one is they are realizing that they are running out of experts. Maybe not today, but if you set up an automation cell at the moment, I mean the life cycle 5 to 10 years, and somebody needs to update, upgrade your automation cell, and they realize that it's more and more difficult to become these experts, and that it takes very long to implement changes. So this is something I think people need to understand. And the other thing is that the automation world is changing very quickly. I mean, 2 years ago, nobody was speaking about, let's say, large language models. Now it's a hype. We will see where it ends. But I think as usual, you have this exaggeration, and somehow I think we will see some parts of large language models entering automation. At what level, at what degree? Question mark. But these changes are so quick and fast that they need to understand, okay, I need to have some solution to integrate upcoming trends, upcoming technologies, upcoming solutions into my existing software environment. So at the moment, you don't set up an automation cell and it's running for 10 years and nobody will touch it. I think this we will see less and less.
What do you think are the biggest obstacles right now to adopt automation?
I think the biggest obstacle still is fear. So if I look at companies which have a very low level of automation, so a lot of tasks are done manually, I mean, it's working. They have a huge pressure, of course, on a cost level, but automation always requires a certain investment. And I think for those companies or those people, it's a new technology and it's expensive. And that makes you somehow fear whether you're going the right way. And that's why I like this incremental approach very much. So you can start with a small solution. You can get used to it. You see what skills you need to develop in-house, what skills you can purchase from an external partner. And then once you feel comfortable, you can do the next step. But I think fear is one of the biggest obstacles at the moment.
Now talking about the future, would you just start talking about large language models? What do you think are going to be the next, maybe not disruptions, but what can we expect from the software world in the coming years that may change the industry?
Okay, maybe two perspectives. So I think we will see more and more realistic simulations. And if we do it right, then we can write our code against a simulation and we can test it automatically. We can make error or fault injection in simulation. We can deploy in a cloud environment, we can deploy the simulation thousands of times simultaneously and do optimization. And once this is done, we can, at least in my vision, we can use the same code deployed on the real machine and it's running. So I think using simulation, using software to develop software, this is something we will see more and more. So we can increase code quality, we can increase robustness, and we can also do it vice versa. So once an automation cell is running, you have very often engineers doing some final optimization on the shop floor. And this needs also be deployed in your simulation environment. So because you need to have both, as you know, these digital twins, so both needs to be more or less exactly the same. So this is something we will see. So decoupling software development from the availability of hardware. This is something I think will really be a big, huge step. Most important, good simulation, physics engine integrated, and it needs to be the same code. So it doesn't make any sense to develop something in a simulation and then say, okay, but this was a code dedicated for a simulation tool, and then I need to rewrite everything. No, this does not make sense from my perspective. And the other thing I think is these, either it will be large language models or not, but somehow to support people. So if you have, for example, let's say an error message, machine failure, so somehow use machine learning and existing tools to guide the serviceman, for example. Okay, I have seen this error and I have learned all these now manuals and handbooks, and I can help you to find the root cause, for example. Now this would be perfect.
That would be very helpful.
Yeah.
You talk about simulation, digital twins. As of today, is digital twins and simulation a marketing tool, or is it something that is really being used and is useful in the industry?
I think both. So we see simulation as at the moment, part of the sales process. So because you can show your customer very quickly, okay, look, this will be the layout, for example, of your factory or of your automation cell. So it's very often used as part of the sales process. And on the other side, we see also simulation now in let's say in cell layout optimization. Am I capable to reach, for example, the cycle time? Here, I think it's also a standard tool. Yes, that's quite common already. So, for example, in commissioning, you have a customer saying, okay, I want to have, let's say, 30 picks per minute. So you can set up a simulation, you can integrate the robot dynamics, you can integrate, okay, how long does it take for the camera to detect the items to be picked, and then you can simulate the cycle time, for example. Yes, that's quite common.
But then you run it on a real machine and you realize that the parts fall when it goes at that speed.
Yep.
So right now the simulation simulates the characteristics of the machine, of the robot, of the gantry.
Yep.
But the real world, then you face it. And will we see better simulations in the future?
Definitely, yes. Because I think if you look at the gaming industry, I mean, they have fantastic physics engine. They have fantastic graphics. They did a very good job. And I think what we will see is that a lot of these things now will be integrated into simulation environments, simulation tools for industrial applications. Yeah. So the gaming industry is far ahead with physics, with respect to physics engines, for example. Yeah. So we will see this. Yeah, definitely.
So going back to Voraus, there are these black box solutions in the industry, especially for control of machines. Some people complain about performance, for example, that you can reach if you want to implement specific control algorithms or implement different vision systems or perception. Where do you see the future for this side of control? Are we going to better black boxes or more open architectures where the customers can program whatever they want?
So in my ideal world, it would all be about open interfaces. Because we have so many different customer-specific requirements. I think for a hardware or, as you said, black box supplier, it will be maybe even impossible to fulfill all these requirements. So you will always be lacking, for example, with respect to certain features or with certain objects you cannot detect. And I think what we see is that the customers we are working with, they are requiring that they are able to add something on their own. They want to have this flexibility because they know once they are in this vendor lock, it becomes very, very expensive for them to have a new feature, a new functionality or something else. So they are really insisting on, okay, I want to have either open interfaces and do things on my own, or if this is not possible, I want to have the possibility that I can exchange this component because maybe a competitor has a better solution and I then want to implement the better solution. So it's either this or that way.
This is happening for machines, but it's also happening, for example, for fleets of mobile robots. When talking about the management of mobile robots, for example, also for the factory, do you see the future more in cloud or in-house?
Oh, I'm not an expert in fleet management, so for me that's very, very difficult to answer. So
also for factory automation.
Yeah. So what I have seen a very big requirement is that things are running on premise. So there are companies which have very strict rules. They don't want to have any external connection. So on-premise means either edge device or an in-house cloud solution. At least that's what we have learned. And if you look at cybersecurity, for example, and how is it called, Cyber Resilience Act or Cybersecurity Act from the European Union, I mean, it's becoming more and more important that either it's running on premise or that you have a dedicated software architecture and dedicated processes dealing with cybersecurity threats. So cloud, from my perspective, of course, is very often very convenient because you don't need to manage your cloud on your own. So you have an external supplier, but a lot of companies are afraid of data leakages and cybersecurity attacks. So my feeling, but that's really my gut feeling, it's more in-house, at least at the moment.
But do you think it doesn't matter the size of the company? How can they have better infrastructure, better maintained infrastructure than, for example, Amazon or Microsoft? Does it make sense to think that it will be more safe when Amazon, for example, is dedicated full time to make sure that that's the safest solution?
I think it's not about better infrastructure. I think it's more about protecting my intellectual property. So
let me ask it a different way.
yeah, okay.
Where is your money safer? At the safe at your home or at the bank?
Good question, even a philosophical question. I don't think there is a black and white answer. I mean, I have, let's say, so in my private space, I have friends. They're saying I'm not running a local NAS because I can make it as bulletproof as Google can. And I have friends and they're saying, never ever I'm going to give my private documents to Google. So I think it really depends on the personality. Yeah, and I think we have in industry maybe the same. I'm fully with you. A company can never afford so many cybersecurity experts like Google, Amazon, or Microsoft. I think they're more afraid of data leakages, access of government. If you look at China, for example, so monitoring or gaining access to your core IPs, I think these things are very important. And then maybe it's not about being better. Maybe it's more about feeling better.
For you and other companies that are deep into automation and software, in your day-to-day you see solutions that are highly automated. But maybe when you look at the actual penetration in the industry, automation is not that high. Other countries, for example, have had like 5-10 year plans to automate everything and have been very successful. Maybe in Europe, we are lagging behind. Also maybe in the US. What do you think is the gap, or how can we close that gap of automation?
Okay, so during our journey, we have seen, let's say, two different types of customers. So there are customers where IT or automation is part of their DNA. So they are very familiar. They already have a high degree of automation. They really have a vision where to go. So as I just said, let's get rid of all these black boxes, become more flexible, integrate new technology. They are always evolving at an amazing speed. And they know the obstacles they have, and they have a plan how to overcome. But you're totally right. On the other side, we have a lot of companies lagging behind. And we see this economic pressure. So we have countries with lower wages where manual work is cheaper, and there is a lot of economic pressure. But still, those companies, they know that they need to do something, but they don't exactly know what to do and what are the right steps. And I think this is the other, let's say, it's not 50%, but the other type of companies we are dealing with. And I think for those, an incremental step-by-step approach is very important, because, as I said before, they fear that they are taking or making the wrong decisions or walking into the wrong direction. And at least I can say what we are doing to overcome this. So we are starting with a very short workshop. We are collecting requirements. We show them a quick simulation, a software architecture, how things could work from our perspective. We show them how to implement this. And what is very well appreciated, so our software also runs in a virtual environment. So we can give them our core technology, and they can program the robot. They can integrate a certain, we call it 3D assets, so certain components in the simulation, and they can get used to it. So they can program in Python, they can do no-code programming, and they somehow, hopefully, overcome this fear. And once they are familiar, and say, okay, this could be the right way. We start with a very small project, not in a productive environment. Once again, to showcase, okay, things are working, to talk with their employees, with their shop floor employees, and even integrate those peoples into the development of the MVP. So we really need to make sure that we don't lose people because they are afraid maybe of losing their job, for example. No, these automation guys are coming and 1 year later, no, I'm laid off. No, that's not the case. So we need to integrate those people into the automation journey. And once we have this MVP, we start with the next step where we say, okay, now let's go into serious production and then maybe into scaling or not scaling, depending on the customer. And well, this takes a lot of time. So we are talking about sales cycles, maybe 6 months or even longer.
You mentioned at the beginning of the podcast this skilled labor shortage, also this lack of people that can, for example, develop an application for KUKA or for another robot. Even mid-size and even bigger companies, one role that has been critical, I believe that is critical in automation, is of the integrators. Okay, they rely many times on integrators because they can concentrate and try to keep this skilled labor and work for many companies. So my question is, how does your solution, how integrators can also be able to work with your solution to help their customers?
So from our perspective, there is hardly any difference. So if we are talking with, let's say, big customers, they usually have, let's say, their in-house integrators, though they have their own dedicated department, group of people which are really able to set up an automation cell. They have all the skills necessary. They even can make the final CE approval. So for them, there is no difference because we are just, let's say, a different software supplier. And for the integrator, I mean, basically it's the same. So we provide them with our software. We are doing first projects together so that they can get used to our software, that they can get used to this approach. And usually they see, oh, it's, let's say, much more fun because I have this now modern tool environment. And they see, okay, we are faster. We are much faster if we do it the new way, then we stick to the old way. So this means they have shorter development cycles. They can offer at reduced costs or they can make huge profits. So for them, it's really easy. Let's put it that way. It's really easy to work with our software and to gain experience, and they get an, let's say, competitive advantage.
Tobias, thank you very much for sharing your knowledge, your experience, and talking about intralogistics and robotics and your experience with Voraus. Hope to see you back soon, and thank you very much.
Thank you very much for inviting me. It was
Pleasure.
Pleasure.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.